Okay, so the last video that I made cut off here. So I'm going to start on the Math Minute for Friday. Again, you don't have this paper in your packet. I'm just making that clear. It didn't get copied properly, so you need to access this page on Student View or Parent View. Okay? Or you can look at the video, pause it here, write down what you see, attempt it yourself, and then press play and see how to go over it. All right? Okay, so it says, look at the table. Based on the information, what is the total cost of 10 notebooks? It gives you the cost of 5. So we need to figure out the pattern between this column, number of notebooks, and this column, total cost. So let's see the relationship between this column and this column. To get from 1 to 3 5/10, there's two things we could do. We could add 2 5/10, or multiply. Multiply 3 5/10. So what we can do is try it in the next row here and see what works. How do I get from 2 to 7? Well, if I were to add 2 plus 2 5/10, I get 4 5/10, which is not 7. So this one, this method, adding, doesn't work. Let's try 2 times 3 5/10. All right, 3 5/10 I'm going to put at the top because it has the most number of digits, times 2. All right, and there is 1 digit to the right of the decimal point here. So my okay, sorry, having some, I think, internet problems. So I just moved to a different location. Hopefully this works better. All right, anyway, this factor here has 1 digit to the right of the decimal point, which means my product should have 1 digit to the right of the decimal point. So I should get 7, which I got. So this method works. All right. To get from this column to this column, I am multiplying 3 5/10. By the way, that kind of makes sense. If a notebook is $3.50, then if you buy 3 of them, you'd be doing 3 times $3.50. Okay? So we can skip ahead to 10 now because we figured out the pattern. All I have to do is do 10 times 3 5/10. Which, by the way, some of you can hopefully do in your head. You're going to get 35, right? You're just moving the decimal point. But I'll do it just for the sake of doing it. 5 times 0 is 0. 5 times 1 is 5. I'm going to put a 0 here because remember when I'm multiplying with decimals, pretend like the decimal isn't there. Okay. 3 times 0 is 0. 3 times 1 is 3. My answer is 350. Okay, now I need to figure out where to put the decimal point. And I was supposed to estimate to begin with, but I didn't. Oops. 3 5/10 rounds to about 4. 10 times 4 is 40. So my answer should be close to 40. That helps me figure out where to put the decimal point. It wouldn't go here because that would be 350 and that's nowhere close to 40. 35, that is close to 40. That would make my estimate pretty good. $3.50, That's nowhere close to 40. It also doesn't make sense because one notebook is $3.50. So 10 notebooks has to be a lot more than that. So the best place to put the decimal point is right here, in between the 5 and the 0. $35. My answer? $35. Decimal point. There we go. Okay, so no, minimize you. Okay, let's scroll down to the next page. All right, so it says, and you know what, I'm going to zoom out here and give myself a little bit more room because this is going to require a lot of work. There we go. Okay, so it says write each of the numbers below correctly on the number line. We've got 0, 1, and 2. Okay. In between 0 and 1, I'm just going to mark a space for 1/2. And in between 1 and 2, I'm going to mark a space for 1 1/2. There's 2 ways to write half. You could also write 5/10. Okay? Alright, so looking up here, I'm going to go ahead and start with the ones that I think belong in this range, between 0 and 1. So that's not this one here. We'll come back to this one. It's also not 1 in 25/100ths. We'll come back to that one as well. Those ones are going to be greater than a whole. We'll start on the left. 9/9. Okay, that is equivalent to 1 whole. So, put a little check to indicate that I've done that one. And I'll put it right here. 9/9 is the same as 1 whole. Remember, this line right here means divide. 9 divided by 9 is 1. Okay? Alright, then I've got 6/10. I'm just kind of going in order from left to right here. 6/10. Alright, well, I see 5/10 is equivalent to 1/2. If I were to compare 5/10 to 6/10, 6/10 is greater. Alright, so 6/10 is going to be, we'll put it right here. Check. Okay, 4/12. 4/12. So, couple of things. There's a lot of ways I could figure out where to put this fraction. First of all, I know that 6/12 is equivalent to 1/2. 4/12 is less than 6/12. The denominator is the same, so I can compare the numerators. 4 is less than 6. Well, if 6/12 is here, then 4/12 has to be below that, about here. All right, now the other thing you can do is simplify 4/12. They share a common factor. They share a common factor of, alright, let's see, working with, trying to get my pen to be more effective, there we go. They share a common factor of 4, so that simplifies this fraction to 1/3. So you could kind of think about it, between 0 and 1, can you divide this into thirds? 1/3, 2/3, be a little bit past this actually, 2/3, 3/3. Yeah, this would be about where 1/3 is. So that works. Alright, now I've got 87/100ths. Okay, it's written as a fraction, so my best bet here is to try and figure out where it belongs in this range. So let's write 6/10, 87 hundredths, and 1 whole. We sort of go from left to right here. When we go from left to right, I see that 1 whole is the greatest. 8/10 is greater than 6/10, but it's less than 1 whole. Because 87 hundredths rounds to about 9/10, it's probably closer to 1 whole. We'll put it right here. All right, last is 1/11. Okay, 1/11 has to be pretty small because if a whole were broken up into 11 equal pieces, that means that it's broken up several times. One of those would be pretty small. So I'm thinking it's going to be pretty close to 0, but to be sure, let's compare it to 4/12. Make sure it's less than that. Remember, 4/12 is equivalent to 1/3. It's really easy to compare unit fractions. 1/11 and 1/3. Think about a whole. If a whole were divided into 3 equivalent pieces, each piece is not going to be that small, right? But if the whole were divided into 11 equal pieces, oh gosh, this is going to take some work here. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They're not equivalent. Sorry about that. But you can at least see that 11ths are definitely a lot smaller than thirds. Okay? That's why comparing unit fractions, ooh, no, that's not what I wanted. Unit fractions is a lot easier. So 1/11, it's a lot smaller than 1/3. Okay, we're not done though. Don't forget, we still have to come up here and place 1 3/4 and 1 25 hundredths. Okay, so 1 3/4. I can divide this space here into fourths. 1/4, 1 1/4, 1 2/4, 1 3/4. There we go. So this one, 1 3/4, we've got it. It's right there. And I'm going to get rid of all this right here because it's distracting. Okay, so then the last thing that we need to place is 1 25 hundredths. I know that 25 cents a quarter is 1/4 of a dollar. So it's helpful to have memorized that 1/4 is the same as 25 hundredths. That is supposed to be a 5. If you know that, then you know that 1 1/4, which we already labeled on our number line, is the same as 1 25 hundredths. If you didn't know that, there's always a way. You could simplify 25 hundredths by finding common factors. Okay, they're both divisible by 25. If you wanted to do it really fast. They're also both divisible by 5. And again, divisible by 5. 25 hundredths is the same as 1/4. Okay? That was a little messy. Sorry. Hopefully you were able to hang with me. All right, let's move on to Tuesday. And I'm going to zoom in. It says compare using less than, greater than, or equal symbols. We'll start with the first one. Three-fourths and 76 hundredths. Okay, we need to figure out, in order to compare these, it'd be helpful if they were both decimals. So we should turn 3/4 into a decimal. There's a lot of different ways we can do this. I just showed you how 1/4 is the same as 25 hundredths. So if I know that, then I can figure out what 3/4 is. If 1/4 is 25 hundredths, then 3/4 would be 25 hundredths times 3. You might be able to do this in your head. That'd be pretty cool. 2 digits to the right of the decimal point in this first factor. So that means my product should have 2 digits to the right of the decimal point. 75 hundredths is the same as 3/4. Okay, so now I need to compare it to 76 hundredths, which you should hopefully be able to do. I like to write them on top of each other. Okay, I'm going to attempt something. Nope. Sorry. Bear with me. This is how we're taught in class to use an index card or even our hand. We start with the largest place value. 7/10 and 7/10. We can't compare them, they're the same. So now we look at the hundredths place. 6 hundredths is greater than 5 hundredths. So that means that this decimal is the greatest. All right, now, as many of you know, I used to teach second grade. This is what I taught my second graders. I'm going to share it with you now. I'm going to zoom in. If 76 hundredths is the greatest, then it gets 2 dots, because it's the greatest. 3/4 is the least, it only gets 1 dot. And you connect the dots. There you go. 3/4 is less than 76 hundredths. All right, number 2. Get rid of that one, get rid of this one here, so that we can really focus. 1 and 24 hundredths. How does it compare to 1 and 3/8? Okay, so for this one, we can, there's a couple of different things we could do. 24 hundredths, that's about 25 hundredths. So we could say that 1 and 24 hundredths is about 1 and 1/4. It's better to compare fractions when they share the same denominator. So I'm going to say that's equivalent to 1 and 2/8. Now I can compare 1 and 2/8 to 1 and 3/8. 1 and 3/8 is the greatest. Like that. Okay, so that's one way to do it. It's useful to use multiple strategies, so we can check our work. Another way to do it is to divide out. let's convert 1 3/8 to a decimal. Remember, that line in the middle means divide. So I can do 3 divided by 8. Now remember, the 3 is the dividend and 8 is the divisor. This is different than what you might be used to from dividing in the past. Okay, I'm going to do my count bys and I'm not going to forget this time. 8, 16, 24, 32, 40. That's supposed to be 48. 56, 64, 72. Okay, I don't really need to keep going on and on and on. 80. Oh my gosh. All right. So let's go ahead and divide out and see what we get. Step 1 is divide. 3 divided by 8. That's a 0. 8 goes into 3 0 times. Now I'm at multiply. 0 times 8 is 0. Now I'm at subtract. I get 3. I'm going to run out of space, I can tell already. Okay, now I'm going to check 3 is less than 8, so I can bring down. Now I know, and I know you know, that 3 and 0 tenths is equivalent to 3. So if I do that, it doesn't change what I'm dividing. But this helps me because now I can pretend like that number is 30 when I'm dividing. And I'm not going to forget my decimal point. Right there. Okay, 30 divided by 8. Well, I don't want to go to 32. That's too big. Let's do 24. So, 30 divided by 8 is 3. 3 times 8 is 24. Subtract, and I get 6. 6 is less than my divisor. 6 is less than 8. So, I can bring down. 3 and 0 hundredths is still equivalent to 3. 60 divided by 8. Okay, let's look at my count bys. 56 gets me there without going over. So, 60 divided by 8 is 7. Okay. Now I'm at multiply. 7 times 8 is 56. Now I'm at subtract. 60 minus 56 is 4. Check, 4 is less than my divisor, so I can bring down. 3 and 0 thousandths is still 3. Okay, I'm totally running out of space, and I apologize. I'm going to transfer it over here. Ugh. Okay, so I need to do 40 divided by 8. It's right there. 40 divided by 8 is 5. 5 times 8 is 40. I subtract, and I get 0. So I'm done dividing out. This means that 1 3/8 is equivalent to 1. Don't forget that 1, by the way. And 375 thousandths. Now I can compare them. It helps to write decimals on top of each other. It's what we've been practicing. To compare one place value at a time. So I line up by the place values. I can put a 0 there so they have the same number of digits. Alright, let's focus on the ones place. No, don't do that. 1 is the same as 1. So I need to go to the next place value. that didn't work. We'll do it like this. 1 is the same as 1, so let's go to the next place value. 2/10 and 3/10. 3/10 is greater than 2/10, so that means that this decimal is greater. And we got that right. All right, so now let's do the last one here. Three and 4/5, and we're comparing it to 3 and 8/10. All right, so we're comparing two fractions. One way to compare two fractions is to make sure that they have the same denominator. So, let's see, 10 is greater than 5, so let's worry about changing this one. 4/5, let's make it have the same denominator. Let's make it be a 10, like this fraction. To get from 5 to 10, we multiply times 2. I have to do the same thing to the numerator. 4 times 2 is 10. 4 times 2 is 8. So that means that 3 and 4/5 is the same as 3 and 8/10. We know that from skip counting fractions to find equivalent fractions. There it is. That means that these two fractions are equivalent. Now, just because it's helpful to do multiple strategies, you could divide out 4 divided by 5 just to make sure you get 8/10. I'm going to go ahead and do it pretty fast because this is, we've already proved it to be true. So now I'm doing 40 divided by 5, which is 8. There we go. 8/10. We got it. Okay, Wednesday, and I'm going to zoom out. 5th graders want to measure how far they can jump. All right, so at recess, Nicole jumped 2 and 5/6 feet. Ellie jumped 1.5 feet, and Sam jumped 2 and 2/3. That's important. That's important. That's important. They want to know how much they jumped all together. So let's do a little bar model. Okay, it looks like Nicole might have jumped the most. And for Nicole, Sam, and then Ellie jumped 1 and 1/2. That should be a smaller bar. She didn't jump as far. Looking at the bar model, I can tell what operation I'm using. I'm adding them together. Okay, so let's, you can go about this a couple different ways. It doesn't matter the order in which you add. I'm going to start by adding or finding the sum of how much Nicole and Sam jumped. And then I'll add, once I find that sum, I'll add the amount that Ellie jumped to that. 2 and 5/6 plus 2 and 2/3. So when we did our fractions unit a few months ago, we had a step-by-step process for adding fractions with unlike denominators. Step 1 was line them up, which we did, so we're good. Step 2 is find common denominators. Common denom. Okay, so if you're at home and you're doing this, double check that's what you did. You can't add two fractions together unless their denominators are the same. Or unless you convert them to decimals, which we're not doing here. Alright, so I see 2/3. That 3 is a smaller denominator, so let's skip count it until we get a common denominator. And there we did. 4/6 and 5/6. That'll work. They have the same denominator. So now, if you're at home, you can rewrite this, but I don't have a lot of space. I'm actually just going to erase this and rewrite it. I prefer that you don't erase your work because it shows the thought process, but they didn't really give us a whole lot of space, so sometimes we have to make do. Step 3. Once we have the common denominators, add. Or subtract, but in this case add. Alright, 5/6 plus 4/6 is going to be 9/6. 2 plus 2 is 4, so we got 4 and 9/6. Alright, a 5th grade mistake that is common is forgetting the whole numbers, so don't forget to add the whole numbers there. Alright, 4 and 9/6. Step 4, if you're adding, you want to check, did you get an improper fraction? We did. 9/6 is improper because the numerator is greater than the denominator. Alright, so you guys know a couple different ways to convert an improper fraction to a mixed fraction. I'm going to do it both ways for the sake of letting you choose. Give you a moment to try the one you like the best. Trying to give myself more space. Okay, so 4 and 9/6. For now, I'm actually going to keep that 4 off, and I'll just focus on the fraction part. 9/6. Let's subtract out wholes until we get to a proper fraction. 9/6 minus 6/6 is 3/6. That's a proper fraction. This right here is 1 whole. That means that 9/6 is the same as 1 and 3/6. There's another way to do this. You can divide. 9 divided by 6. When you divide, you get 1 with a remainder of 3. So, we go back to the divisor, and that becomes the denominator. 1 and 3/6. Same thing. Good. 2 strategies, same answer. That's good news. Alright, so 9/6 is equivalent to 1 and 3/6. So, let's put these wholes together. That becomes 5 and 3/6. But we're not done. Now we need to add how much that Ellie jumped. Oh, I forgot something. The next step. Simplify. I didn't really worry about simplifying because I still had to add how much Ellie jumped, but for the sake of making sure we're doing the steps all the way through, let's go ahead and simplify 3/6. They share a common factor of 3. What half? How much did they jump all together? 5.5 feet. My T didn't show up, but it's there, I promise. Okay. Again, I hope that you're not erasing all your work. I hope that you have a separate sheet of notebook paper and you're showing everything. But I am going to erase this because I don't really have that much space. Alright, so together, Nicole and Sam jumped 5.5 feet. Let's add it to how much Ellie jumped. Line them up. find common denominators. Well, since we simplified before, they are common denominators, so we're good there. Add. Okay, 1/2 plus 1/2. 2 halves. 5 plus 1 is 6. All right, 6 and 2 halves. Think about it. What is that equivalent to? Well, we ended up with an improper fraction here. So, 2 divided by 2 is 1. That makes this equivalent to 1. 7 whole feet altogether. By the way, 2 halves, the other method works. Subtract out a whole. What do you get? 0. That equals 1 whole. Boom. They jumped 7 feet altogether. All right, Thursday. Okay, I'm going to pause here for a second, not only because I need to readjust, but also because I know you don't have this in your packet. Just want to reinforce, you've got to access this online, or pause the video right now and just record this on a sheet of notebook paper, try it yourself, and then play the video and check in and see how you did. All right, so it says, what fraction below has a value less than 1/5? So on a number line, there's 0, there's 1/5. We're looking for this area here. The cool thing about this is that most of them are unit fractions. This one, this one, this one, this one, and this one are all unit fractions. It is super easy to compare unit fractions because I will show you why. Let's say that bar represents 1 whole. The denominator tells you how many pieces you cut it into. So 1/2, 2 equivalent pieces. That means 1/2 is going to be pretty big. See? 1/3, we've got 3 equivalent pieces. Thirds are going to be pretty big, but not as big as halves. Okay? Let's skip 1/7 and go to 1/4. 4 equivalent pieces, which makes 1/4. Fourths are going to be a little bit smaller. Notice the more we divide up the whole, the smaller the pieces are. And then 7ths. Ugh, this won't be fun. 1, 2, 3, 4. Nope. There we go. 7ths are even smaller because we're dividing the whole into 7 equivalent pieces. Okay, so for unit fractions, what we're realizing is the larger the denominator, again, this is only true for unit fractions, the greater the denominator, I'll write it out, the smaller the fraction. So 1/99 is going to be even smaller. 1/200 is going to be even smaller. All right, so let's go back to the question. The question was, which ones have a value less than 1/5? Okay, so that means that 1/2 is greater than 1/5. So is 1/3. That's greater than 1/5. 1/4, that's going to be greater than 1/5. Remember, the greater the denominator, the smaller the fraction. But 1/7, No. Mistake. They're looking for, oh yes, a value less than 1/5. Man, I had that right. Got myself confused. So 1/7 is less than 1/5. Let's write it out. The greater the denominator, the smaller the fraction. Okay? So C. All right, 2/3 is not a unit fraction. So let's think about it though. If 1/3 is greater than 1/5, then 2/3 definitely has to be greater than 1/5 because it's 2 times 1/3. So this one, it's not going to be less than 1/5. Okay? There's only one fraction that's correct. 1/7 is less than 1/5. All right, this one. Which fraction below has a value greater than 2/3? Gonna give myself some space once again. Greater than 2/3. All right. Okay, so for these ones are all unit fractions, but 2/3 is not a unit fraction, so we have to think of a different strategy this time around. All right, greater than 2/3, not going to be 1/3. That's going to be less than 2/3. Using the same principle we just discovered, 1/4 is going to be smaller than 1/3. If 1/3 is less than 2/3, then 1/4 also has to be less than 2/3. Okay, let's look at 1/2. 1/2 and 2/3. We can compare them by finding common denominators. Let's skip count. Aha! Common denominators. Nice. So we've got 3/6 and 4/6. This means that 4/6 is equivalent to 2/3. 3/6 is equivalent to 1/2. 4/6 is greater than 3/6, which means that 2/3 is greater than 1/2. Hopefully you followed all that. What we're saying is that 2/3 is greater. Not 1/2. Okay, 4/6. Oh man, I shouldn't have just erased that because I just saw that 4/6 is equivalent to 2/3. When you skip count 2/3, like I literally just did and then erased, you end up getting 4/6. These are all equivalent fractions. So that's not going to be greater because it's equal to. All right, so hopefully 7/8 is greater than 2/3 because we eliminated all the other ones. Okay, so 7/8 and 2/3. It might help us here to divide out these fractions. I want to make sure I give myself enough space. Let's do this. 7 divided by 8. I'll do my skip count. My count by is over here. Okay. All right. So I'm going to start with dividing. 7 divided by 8 is 0. Multiply. check, 7 is less than the divisor, so I can bring down. Now, 7 and 0/10 is still 7. All right, so now I'm doing 70 divided by 8. 64 gets me close without going over. So that means 70 divided by 8 is 8. 8 times 8 is 64. I subtract, and I get 6. 6 is less than the divisor, so I can bring down 7 and 0/100 is the same as 7. Now I'm doing 60 divided by 8. Now I can get close with 56. That means 60 divided by 8 is 7. Now let's multiply. 7 times 8 is 56. Four is less than the divisor. So let's bring down again. 40. Well, this is going to work out perfectly. 40 divided by 8 is 5. 5 times 8 is 40. Subtract. Now I finally have a 0. 875 thousandths. All right. Now I need to divide out 2/3. I'm going to erase this so that I have space. 2/3. By the way, some of you might have these memorized. If you do, that's awesome. I need more space than that. There we go. Okay, do you need to do your count bys for 3? If you do, do them now. Doesn't hurt. I always make mistakes doing my count bys because I rush. Okay, there we go. All right, so 2 divided by 3 is 0. Then I multiply, subtract, check. 2 is less than the divisor of 3, so I can bring down. I'm going to go a little faster. Okay, oops, that decimal point is supposed to be right over. There we go. 20 divided by 3. Let's go to 18. 6 times 3 is 18. I subtract and I get 2. 2 is less than my divisor. So I bring down. Wait a second. Flashback. I'm getting 20 again. So that means that if I keep dividing, I'm going to keep getting that 2. So that 6 is going to go on forever. If you were to take 2 wholes and divide it by 3, it would keep giving you 6, repeating for infinity. We show that by putting a line on top of the 6. You might also see it like this. Okay, so now we can compare the 2 decimal values. Since 2/3 is the same as 6 repeating, let's write them on top of each other. $875 thousandths and 666 forever. And let's go ahead and go 1 place value at a time. Start with a 10th place. 8/10 is greater than 6/10. That means that 7/8 is greater than 2/3. All right. The answer is E. You made it to Friday. Nice. 2 problems. And a 49-minute video. My gosh, I'm sorry. All right, so we'll start with 3 and 5/6 minus 2/3. All right, and I'm going to give myself lots of space here by getting rid of that. Okay. So step 1 when we're dividing with subtracting is to line them up. Line them up. Let's do it. Step 2, common denominator. Common denominator. Okay, so let's skip count 2/3. See if we can get to that 6. 3, 6, there it is, 9. You could keep going, but there's no point. 4/6 is equivalent to 2/3. Okay, they're the same. I'm actually going to just erase and put 4/6 there. On your paper, I would recommend you just rewrite this just to show the process. All right, once you find a common denominator, subtract. Don't forget the whole numbers. 5/6 minus 4/6 is 1/6. 3 minus 0 is 3. 3 and 1/6. Last step, simplify. We don't need to. We're good. So the answer is 3 and 1/6. I will say there is a step in between here. You sometimes have to regroup. That happens if you find the common denominators and you end up with a numerator up here that is less than this numerator here. Okay, we didn't have to do that. Let's go to the other problem. There it is. 5 and 1/4 plus 6 and 2/3. All right. So step 1 is line them up. Line up. Step 2 is common denominator. That's supposed to be a D. All right. So let's skip count 2/3 and we'll skip count 1/4. 3, 6, 9, 12, 15, 2, 4, 6, 8, 10. All right, 1/4. 4, 8, 12, 16, 1, 2, 3, 4. All right, so I finally found my common denominator. 8/12 and 3/12. Awesome. So I can rewrite this over here. Instead of 5 and 1/4, I can write 5 and 3/12. Over here, instead of 6 and 2/3, I can write 6 and 8/12. The next step is to add. And then at the bottom, I'm going to check for an improper fraction. 3 plus 8 is 11, so we've got 11/12. Don't forget the whole numbers, 11 and 11/12. It's actually a proper fraction. The last step is simplify. I don't need to because 11 and 12 don't share common factors besides 1. So my answer is 11 and 11/12. And I'm done here. So there you go, 5th graders. Glad you got the chance to check your work. The next videos that I'll bring up is going over some more math and some of these daily review quizzes. Okay? Awesome job.